Hey grade 7s, this is 9.7 subtracting integers, the last video in the 9 unit and also the fastest. I will be like the Flash after 6 cups of coffee. Alright, a little quick review. What was the trick for adding integers? It has something to do with this little red box there. Not that one. The red box that I'm trying to grab right there. What was it? Do you remember this? Instead of seeing 2 signs, we're going to simplify to 1. That meant you take your little red rectangle, you put it between the 2 integers, and you see, oh, these are different, so therefore it's subtracting. Well, guess what? Same thing for subtracting. It doesn't make a difference. So if the signs are between the integers are the same, replace them with a positive sign. In this case, we have 2 signs that are the same, subtracting a negative. Look at that. It's amazing. Those 2 become 1. They become positive. Subtraction of subtraction is addition. Remember, addition always goes to the right. So this says that we're starting with 3, right here, and it says add 2 integers. Always to the right. We end up at 5. Rule number 2, if the signs between the integers are different, replace them with a negative sign. So we're subtracting. So we take our little handy dandy notebook, it's not Dora, sorry, our red rectangle, and we see that the signs are different. We replace with 1. We are subtracting. And let's go over here. So we're starting at 4, which is right over here, and we're subtracting, so we're always going to the left. We're going 2 to the left, and we end up at 2. Look at this one. Take our handy dandy little red rectangle, -3 minus +1. The signs are different. We replace it with subtraction. Where are we starting? Starting at -3, right here, because that says -3. That's where we're starting. And now we're going to subtract 1. I don't even think about subtraction. I just think about, every time I look at that negative sign, that subtraction, I'm always moving 1. I'm moving to the left. In this case, I move 1, end up at -4. So you try these ones. Pause the video and then give it your best shot. All right, the signs are the same, so replace with addition. We're at -2, we're adding 7. You should end up at +5. And I don't have to put the positive there, it's understood. Number 2, -7 minus 6. Whoa, monsieur, there's only one sign. Yes, there is another sign. There's a sign, it's sous-entendu, it's right there between the 2 integers. This is subtracting 6 positives. So the signs are different, therefore we are subtracting. We're moving to the left. We're at -7, we're moving 6 to the left, so you should end up at -13. This one, signs are the same, we are adding. We're at 8, we're adding 7, we should end up at +15. And finally, our last one, -7 minus -7. The signs are the same, we're adding, you should end up with a big fat 0. So, word problem, always word problems, right? So on April 6, 1971, the highest temperature in Montreal was 5 degrees centigrade, and the highest temperature in Yellowknife was -2 degrees centigrade. What is the difference in temperature? A couple of key words here. Difference. As soon as you see difference, you should be thinking to yourself, subtraction, because that's what difference means. The other thing is, you've got 2 numbers. You've got 5 and -2. We always have to represent these numbers somehow, and so the first number is going to be Montreal's temperature because it's the first one written in the equation. On April 6, 1971, the highest temperature in Montreal was +5 degrees centigrade. So we're going to represent that with +5. The highest temperature in Yellowknife was -2. That's the second number, so we're going to put that one over here. You should have -2. And again, as I said earlier, the question is asking what's the difference in temperature? The difference means subtraction. Okay, no problem. We have 2 signs here, and they are the same. This actually means addition. So the difference between these 2 temperatures is 7 degrees.
That was easy.
No doubt.